Okay, good morning. This is Vectors Part 2, day number 1 on the cross product and the application of the cross product. Okay, first of all, this right here is called the cross product, and the result is a vector. And that vector, let's call it W, right? The resulting vector is going to be perpendicular to A, and it will also be perpendicular to B. All right, so this is different, not the same process as A dot B. Right? It's going to be totally different than that. Now, a cool application of the cross product is going to be the magnitude of the cross product. And the magnitude of the cross product is actually equal to the magnitude of vector A times the magnitude of vector B times the sine of the angle between them. It's pretty cool. You'll see that in just a moment when we get to that slide. Okay, now, vector I and vector I have an angle of 0 between them. So I cross I is going to be the magnitude of I, which is 1, times the magnitude of I, which is 1, times the sine of the angle between them, which is 0. And the sine of 0 is 0, so that'll be 0. Same thing will happen with K. Same thing will happen with J. Now, I'm not going to go into the details and specifics of this piece, but I cross J would be the magnitude of I times the magnitude of J times the sine of the angle in between them, which would be 1 times 1 times 1. I cross K is going to be very similar, except it's going to be -1. If you're very curious about why, we can talk about that on the side. And then over here, we're not going to use each of these three over here, but just so an FYI, when I cross those two vectors, that's what I get. Now, these are the big three that we're going to use today in the mechanics of how to do a cross product. So let's get started. The determinant of A cross B, right? Determinant is just matrix multiplication. That's all it is. Okay, so here's a matrix that's going to represent A cross B. Okay, and how we're going to go about that is pretty unique in nature. You might remember this from some point in your math career, but when you multiply this matrix, I'm going to get three components out. Right? So A cross B is going to give me three components because this will be a vector. I'll get an I portion. I'll get a J portion of this vector. And I'll get a K portion of this vector. Now, what we just did on the last page was when I did the cross product of J and K, I got +1. When I did the cross product of I and K, I got -1. And when I did the cross product of I and J, I got +1. So that's where those coefficients come into play. All right, now how do I get these values here? All right, how do I get the coefficients of each of those components? I'm about to show you. Let me get rid of this. That's kind of confusing me. Okay. So I'm going to make a little rectangle here. This is something you might want to get used to doing. And this rectangle is going to be used to help me to ignore one of my variables when I do the cross product. That's a pretty gross color. Let's use that. Okay, so the first one. When I want the I component, right, I'm going to do the cross product, which is A2B3 minus A3B2. These are just the mechanics of how this works. Okay, obviously we'll do it with numbers in a moment with an example. Okay, now we move it over to J, cover that up. Now we're going to do IK. Okay, so that'll be A1B3. You always subtract on the inside A3B1. Always subtract on the inside. Okay, now let's do K. That'll be A1B2 minus A2, B1. All right. Now you can count on the fact that this will always be positive 1, this will always be negative 1, this will always be positive 1. Okay, let's try an example of that here. Here I've got 3 points. I want to do the cross product of AB and AC. In order to get AB, I got to take B minus A. Remember, head minus tail. And then I got to take C minus A. So B minus A would be 1, 2, 3. I just used points A and B over there to my left. And C minus A would be negative 2, negative 1, 4. Let me check my math here. Negative 1 minus 1 is negative 2. 0 minus 1 is negative 1. 5 minus 1 is 4. Okay, good. Now I take this and I set it up in this determinant form. Okay, so A, oops, I don't want A, I want AC. So if I'm taking AB crossed with AC, that's going to mean I want my components I, J, and K. So my components of AB are 1, 2, 3. My components of AC are negative 2, 1, 4. Now I use the same method I used on the previous page, except now with numbers. So AB crossed with AC, again, cross is different than dot product, is going to be 1 times 1, which is 1, minus negative 2 times 2, which is negative 4. That'll be your I component. Your J component, I'm going to cover up the 2 and the 1, the red 2 and the blue 1. I'm going to subtract whatever I get here. So I'm going to have 1 times 4, which is 4, minus a negative 6, J, plus my K component, I cover up the red 3 and the blue 4. I get 1 times 1, which is 1, minus negative 4. Uh-oh, did I do something wrong there? Yes, I did. I did my first component wrong. I didn't cover up the I. I covered up the K. So let's cover up the I. I get 8 minus 3. Okay, that's better. So it looks like I get 5I minus 10J plus 5K. Let's think about that one more time through, just in case. So cover up my I get 2 times 4, which is 8, minus 3 times 1, which is 5I. Okay, good. For my J component, I get 1 times 4, which is 4, minus a negative 6, which is 10. Good. Cover up my K. 1 times 1, which is 1, minus a negative 4, which is 5. Good. Okay. So this right here would be the resultant vector of AB cross AC. That means that this vector right here is perpendicular to AC, and it's perpendicular to AB. Okay. All right, let's move on to some application. Okay, so you have probably seen in your math career the area of a parallelogram. If I were to sketch a rectangle, right? If I had the base and I had the height, the area is equal to the base times the height. Okay, now the base of a parallelogram and the height of the parallelogram are no different, right? So imagine you had this parallelogram. This is still the base, but the height is now that length, or it could be visualized as that length. Now, if it's a parallelogram and you don't know that height, there is a way to use this acute angle right here to find that height, and we're going to do that right here. So if I were to look at this parallelogram, right, using vectors, I got vector A as the base, and I got vector B over here. I don't have the height, right, because these two vectors are not perpendicular to each other. So if I could find this height, right, and I took the magnitude of A, I would have the area. So the area of the parallelogram would be the magnitude of A times the height. Times the height. Let's figure out how to find that height. Now, if I took that triangle out of there, right, I don't really care about this length at all, but I'm looking for that. I have that angle theta, right? I can find the angle between, and I know this length is the magnitude of B. Well, the way that I would find the height is I'd take the sine of theta, and that would equal h over the magnitude of B. And therefore, h would equal the magnitude of B times the sine of the angle between. So what's pretty cool, right, if I sub in for that height, I sub in the magnitude of B times the sine of the angle between. That looks very familiar. That right there is equal to the cross product. Right? It's equal to the magnitude of the cross product of those two vectors. So if I want to find the magnitude or the area of a parallelogram, I just take the magnitude of the cross product. So here we go. Find the area of the parallelogram ABCD. Okay, so let's just say ABCD looks like this. Let's go like this. Okay, and I'm given A, B, and C. Okay. No, I don't want that. I want to move my C and my D around here. Okay. So let's say I see this parallelogram ABCD, and I know these points A, B, and C, right? All that I need to do is I just need to take the magnitude of the cross product of AB and, oops, try again, of BC and BA. Ooh, golly. Let's go like this. BA and BC. Okay, so here's BA and here's BC. If I take the magnitude of the cross product of those two vectors, I will have the area of the parallelogram. So to find the area of the parallelogram, let's do the magnitude of that. How would I find the area of the triangle formed by those two vectors? Well, of course, it would be the area of the parallelogram divided by 2. Okay, so this would be our triangle formula. This is our parallelogram formula. Let's go ahead and execute that. So first I need to know BA and BC. Let's do those over here. Vector BA will equal all points of A minus all points of B. So that's 2 minus negative 5, which is 7. 5 minus 8, which is negative 3. And negative 1 minus 6, which is negative 7. Okay. Let's do the same thing for BC. Okay, all points of C minus all points of B. Component specific. 3 minus a negative 5 is 8. 4 minus 8 is negative 4. 2 minus 6 is negative 4. Okay, so here we go. Let's do the cross product. So BA crossed with BC is going to equal, let's put in our numbers, 7, 3, negative 7, 8, negative 4, and 4. We'll go through the mechanics of our work here, doing the actual cross product. So I'm going to have an I, I'm going to have a J, I'm going to have a K. All right, let's see what we get. That would be For I would have 12 minus, what is that, 28? 12 minus 28 is a negative 16. Okay, for j, I cover up the 3 and the negative 4. I get 28 minus a negative 56. 28 plus 56, that's 70, 84. And for k, I get negative 28 minus 24. Negative 28 to minus 24, that's a 40, 52. Negative 52. All right, let's check our work just to make sure. Give me a moment. So we'll see what I did over here. Right, this is negative 16 squared. This is negative 84 squared, and this is negative 52 squared. I added all those up. This will be the magnitude of the cross product, square root of 10,016, which comes out to be about 100. This is going to be your area of that parallelogram. Okay, and then of course the area of the triangle would be that value divided by 2, which would be approximately 50. And we don't have units on this, so I'd say units squared. There's your area of your parallelogram, or your triangle. Here's the area of your parallelogram. All right, guys, that's cross product. The magnitude of the cross product is the area of the parallelogram. Good luck, and let me know if you got questions.